Hey all you cool cats and kittens, we are back and today we are in chapter 4.1. We've talked a lot about how to find the first and second derivative. Now we want to talk about what it can do for us. So let's start with a review of what we learned in chapter 2. For starters, if f prime is greater than 0 on an interval, then f is increasing. On that interval. If f prime is less than 0 on an interval, then f is decreasing. On that interval. And we said that if f prime is always positive or always negative, on an interval, then f is monotonic on that interval. So that was what we knew about the first derivative, but we also know some stuff about the second. If f double prime is greater than 0 on an interval, then the graph of f is concave up on that interval. If, on the other hand, f prime double prime is less than 0 on an interval, then the graph of f is concave down on that interval. So the first and second derivatives can help us identify regions of a function that have interesting behavior. So they could help us, if we have a function, we want to graph it, but we really don't know what it looks like, we can look at the derivatives and they can tell us a lot. And now that we've done chapter 3 and we actually know how to find a variety of interesting derivatives, this can be pretty fun and helpful for us. So we'll start by walking through an example where we do this. We find some derivatives and see what they tell us, and we try to draw a graph. And then that's all we're going to do in this video, but then I'll make another video where I go back and kind of label what we did with some formal terminology. So we want to do an example. Ooh, sorry about that. Things got wild for a second there. So example, let's take a closer look at f of x equal to x cubed minus 9x squared minus 48x plus 52. So x cubed minus 9x squared minus 48x plus 52. Okay, well, for starters, we need to find the first derivative. So this is easy enough. F prime of x is 3x squared minus 18x minus 48, and I found that via the power rule. So no fancy rules necessary there, simple product rule. Okay, next, where is f prime greater than 0? And where is it less than 0? Well, that we could be looking all over because, x, this function that we have here, f of x, it's defined from negative infinity to positive infinity. So what we want to do is we actually want to start by finding where f prime is equal to 0. If we know where it's equal to 0, then we just need to look in between each of those points and say, well, what happens on that interval? Because we know between two of these points where f prime is 0, f prime can only be positive or negative. It cannot change. So each time it changes, there's an f prime equal to 0 in the middle. We'll see kind of what I mean by that as we walk through this. But so we need to start by finding where f prime is equal to 0. Let's do some algebra. So here's a great chance for us to brush up on our factoring. So we know we've got 3x squared minus 18x minus 48. We want to know where is that equal to 0. Well, we can rewrite this as 3 times x plus 2 times x minus 8 equal to 0. Well, 3 is never equal to 0. X plus 2 is equal to 0 when x is negative 2, and x minus 8 is equal to 0 when x is equal to 8. So that means the only two places where this happens is x equal to negative 2 and x equal to 8. So it's not 0 anywhere else, just those two. So is that a max or a min? Meaning, is that a high point for this function or is that a low point for this function? We know something happens at those points. We know it's either a peak or like a valley. It's a high or a low, so we want to know what happens. To answer that, we need to know what happens on the other intervals. So I'm going to make a number line. So I'm going to make my number line here. And I'm going to mark x equal to negative 2 and x equal to 8. Those are my special points, and so now I know what happens at those points. I want to know what happens in between them. So here's x equal to negative 2, here's x equal to 8, and I know that here f prime is 0. So to answer this, let's pick some values and see what happens to our derivative. So first up, what happens in the chunk where x is less than -2? Pick a number that's less than -2. I'm going to pick -6. So f prime of -6, that's 3 times -6 squared, minus 18 times -6, minus 48. That gets me 168. That's greater than 0, so that tells me f is increasing. I can make note of that here. F prime greater than 0. F is increasing. Okay, what about between -2 and 8? Well, let's pick something in there. 0. 0 is in there. 0 is a nice, wonderful number, so we'll pick 0. F prime of 0 makes our life easy here, so 3 times 0 squared minus 18 times 0 minus 48 gives us a -48, which is less than 0, so f is decreasing. So f prime less than 0. F is decreasing. Okay, what about that last piece? X greater than 8. Pick a number in there, we'll say 10. F prime of 10 is 3 times 10 squared minus 18 times 10 minus 48. That gets us 72, which is greater than 0. So f is increasing. Make note of that up here. Okay, so we know f is increasing until we get to -2, then it starts decreasing until we get to 8, and then it starts increasing again. Cool. What happens at those 2 points? What happens to our function f? So what happens to f at x equal -2 and x equal to 8? Well, at -2, we've got -2 cubed minus 9 times -2 squared minus 48 times -2 plus 52. It's 104. So that's going to be our high point. On the other hand, at 8, we have 8 cubed minus 9 times 8 minus 48 times 8 plus 52, which is -396. So that is a low. So we know we've got a high, it increases until we get to 2, then it's about -2, then it's 104, it goes down again, reaches -396, and then it starts going up again. Can also find the y-intercept. That's an easy point to find that can be a good reference when we're trying to draw our picture. So f of 0 is 0 cubed minus 9 times 0 squared minus 48 times 0 plus, plus 52, which is 52. So that was an easy enough calculation. So now I have a y-intercept Great, we've got 3 points on the graph and we have knowledge of where it slopes up and down. Next, we want to know something about concavity. Second derivative tells us that. So we need a second derivative. So f double prime of x, well, let's take the derivative of our first derivative. We get 6x minus 18. Again, simply via the power rule. Where is that 0? So we know that it's going to change concavity at points where f double prime is equal to 0, and then we'll be able to know again what intervals we need to focus on. So we've got 6x minus 18. We want to know, where's it equal to 0? Well, that's the same as 6 times x minus 3 being equal to 0. That tells us it happens when x equals 3, and that's it. I can draw another number line. This time my number line just has one label on it, and that is the number 3. And we know that at 3, f double prime is equal to 0. So what about when x is less than 3 and when x is greater than 3? Let's pick some numbers again. For x less than 3, we're going to pick 0. So f double prime of 0 equal to 6 times 0 minus 18. So it's negative 18, which is less than 0. So that tells us concave down. Make note of that, f double prime less than 0, concave down. For x greater than 3, we'll pick 6. F double prime of 6 is 6 times 6 minus 18, which is 18. That's greater than 0, so that tells us concave up. Make note of that. F double prime greater than 0, that is concave up. Great, so we have just about all we need to make our graph. And bear with me, I am not good at drawing these, even when I'm not trying to do it on an iPad, so this is not going to be an amazing picture. We have our y-axis, get an x-axis, and then we get our function. So I'll draw my function in a different color. Let's draw our function in blue. Why not? So we know that we're increasing for a while until we get to negative 2. Then it starts decreasing. It keeps decreasing until we hit 8, and then it starts increasing again. So there's our function, and we can label some special points on it. So here we know this is the point negative 2, 104. This is the point 0, 52. And this is the point 8, negative 396. So then if you go check Wolfram Alpha or Maple, your graphing calculator, whatever, go ahead and graph the function f and see how we did. We did pretty well. We did pretty well. So, and we gained all of that just by looking at derivatives. We didn't look at any pictures of this function, and we are still able to draw the graph. So that's the end of this video, and next time we will talk about the terminology.